Hello everyone. Let us start our discussion on filters. What are filters? Filters are electronic devices used to eliminate undesired frequency from the input AC signal. Okay, input AC signal. So it is an electronic device which is used to eliminate undesired frequency from the input signal. So we can design the filters based on our requirement. What type of filters we need, what frequency filters we need. So based on our requirement, we can design the filters. Okay. So what are the basic types of filters? Basic types of filters are mainly we have active filter and number 2 passive filter. Okay, then what is meant by active filter? Okay. What is meant by active filter? Number 1, active filter. Active filter is one which is used or which is designed using active components. Like, what are active components? Like transistor, okay, diode, and then you can also use some amplifier in the circuit, etc. These are all the called as active circuit elements. Transistor, diode, amplifier, etc. These are called as the active circuit elements. So when I design a filter, I have to use any one of these components or all the three components, all these active components in the circuit, along with RLC, resistor, inductor and capacitor. These are called the passive components. RLC are called as the passive components or passive circuit elements. Along with these R and C, if I use transistor, diode and amplifier, then that part of the filter is called as the active filter. Okay, that part of the filter is called as a active filter, right? Okay. And number 2, second one is passive filter. So what is meant by passive filter? This passive filter is designed using a passive components. What are passive components? As I already mentioned, R, L and C. These are passive components. Any filter which is designed using these passive components are called as passive filter. So mainly we have two types of filters, active filter and passive filter. Active filter means a filter which is used, which is designed using an active components like transistor, diode, amplifier, etc. Along with that, R, L, and C is called as an active filter. And a passive filter is one which is used, which is designed using a passive components like R, L, and C. Is a passive. Is it clear now? Is it clear? Okay. Then let us pass on to further classification of the filter. Another type of classification. In these passive filters, okay, passive filters, we have low pass filter, LPF, high pass filter, HPF, and 3 band pass filter, BPF, 4 band stop filter, PSF. So these are the 4 different types of passive filters we come across. Okay, these passive filters are mainly, we are discussing mainly all these filters are mainly using R and C. RC filters we are going to discuss. Okay, R and C, resistance and capacitance. You can construct a passive filters by you may be making use of resistance and capacitances. Okay, mainly we have to discuss only 2 filters, that is low pass filter and high pass filter, how it is designed and how it is working, and what is the expression for the cutoff frequency. Okay, what is the expression for the cutoff frequency, and what are the difference between the low pass filter and the high pass filters. All these things we have to discuss. Okay, let us discuss these things one by one. First, let us consider what is meant by a low pass filter. So, number 1, low pass filter. So here the name itself indicates you that low pass, that means this filter allows only lower frequency AC signal. Okay, it allows only lower frequency AC signal and stops higher frequencies. So low pass filter always allows only lower frequency AC signal and stops higher frequency AC signals. Okay, and how it is designed. Construction. Let me consider the construction of low pass filter. How it is constructed. So usually low pass filter or high pass filters are designed, as I mentioned earlier, they are designed using R and C, resistor and capacitor. Okay, so in designing a low pass filter, let me consider a source of voltage, AC source. Okay, this is from here we have to take V in, and for this I am going to connect a resistance in series. Okay, resistance in series, and now across this we have a capacitor. have a capacitor. Okay, R, and this is C. And output is going to be measured across the capacitor. Here I am going to measure the output. Okay. So this is the simple construction of low pass filter. It's very simple. Construction is very simple. It is constructed using R and C. Resistance is connected in series with the voltage source, and capacitor is connected along with the resistor, and the output voltage is measured across the capacitor. So this is the construction of the low pass filter. Okay, so how it works? Okay, working. For any frequencies, there is no impedance, resistor impedance, change in the resistor impedance to the input signal. There is no change across the R. Whatever the voltage come across here, it will be given to the capacitor. So therefore, at lower frequencies, okay, whatever the input is here, the output will be the same. Input will be whatever the input we give, the same amount of output we are going to get, because there is no potential drop across this resistor. Okay. Now what happens when we increase the frequency of the input signal? When we increase the frequency of the input signal, as you know that XC is equal to 1 over omega C. Okay. As the frequency increases, and right here 2 pi FC. Okay. As the frequency increases, frequency in the denominator, therefore the impedance, capacitor impedance increases. Okay. So maximum voltage will be stopped at this particular capacitor. Okay, in this capacitor. Therefore, whatever the input we are going to give, the same amount of input I am not going to get across the capacitor. Therefore, the potential difference goes on decreases. Okay, potential difference goes on decreases. So, at most only to a particular frequency it is allowed. The frequency is allowed. After that particular frequency, the voltage is going to be dropped. That means to say that the capacitor does not allow the frequency to pass through it. It blocks all the AC signals which are having higher frequencies. So higher frequency signals are going to be stopped at this particular end, and it allows only a lower frequency signal. In this way, this filter is acting as a low pass filter. Okay. Up to a particular frequency, this frequency we can select. We have to select, that depends upon the R and C. I can pre-design the circuit by making use of the value of R and C. I can fix the value of FR, cutoff frequency. Okay. Based on that, up to that particular frequency, the frequency is allowed, and all other higher frequencies are going to be stopped. Okay. So the output waveforms I am going to write here. Output waveforms will be something like this. So this is the frequency, this is the output. Okay. So first, this is the maximum value that I am going to give. Okay. This is just for example, if it is a voltage gain I am going to get V0 by Vi is equal to 1. So in the lower frequencies it is allowed. Up to a particular frequency it is allowed. And beyond this particular frequency, this particular frequency, it is not allowed. So this part of the circuit is allowed. This part of the frequency of the AC signal is allowed, and beyond this it is not allowed. It is stopped. In this way, the low pass filter acts in passing the lower frequencies and attenuating or stopping the higher frequencies. see AC signals. Okay. Now we have to derive the expression for the cutoff frequencies. Cutoff frequency. Okay. So in order to define the derive the expression for the cutoff frequency, expression for cutoff frequency. Expression for cutoff frequency. Now let us apply voltage divider circuit divider formula. Voltage divider formula to the circuit. If I apply voltage divider circuit formula to the circuit, I can write V0 is equal to XC divided by R plus XC into Vi. Output voltage is given by XC impedance, capacitor impedance divided by R plus reactive capacitance into Vi. This can also be written as V0 by Vi modulo of this. I will take modulo. So XC modulus divided by R plus XC modulus. Right? So now XC modulus of R plus XC can be given as square root of R square plus XC square. R square plus XC square. R square plus XC square. Therefore, I can write V0 by Vi is equal to XC divided by square root of R square plus XC square. Okay. Now at cutoff frequency, V0 is equal to 1 by root 2 times Vi. So this is the condition. At cutoff frequency, output voltage is equal to 1 by root 2 times the input voltage. If we substitute this value in this equation, 1 by root 2 into Vi divided by Vi is equal to XC divided by root of R square plus XC square. So Vi get cancels and I am left with 1 by root 2, which is equal to XC divided by root of R square plus XC square. Okay. Now let us square on both sides. Squaring on both sides. Then if I square this, I am going to get 1 by 2 is equal to XC square divided by R square plus XC square. Cross multiply. Okay. Then I am going to get 2 XC square. 2 XC square is equal to R square plus XC square. R square plus XC square. Now I transfer this XC square to the left hand side. I am going to get 2 XC square minus of XC square is equal to R square. So XC square is equal to R square. Right? XC square is equal to R square. Or this is equal to, taking square on both sides cancels each other. I am going to get XC is equal to R. XC is equal to 1 by omega C is equal to R, or omega C R is equal to 1, omega C into R is equal to 1, or 2 pi F, omega is equal to 2 pi F into R is equal to 1, or F is equal to, C here, C is here, right, 1 by 2 pi into So this is the expression for the cutoff frequency. Okay, this is the expression for the cutoff frequency in low pass filter. Low pass filter. Okay, is it clear now? Okay. So I have given all the explanation for the low pass filter, how it is constructed, and how it is working, and what is the graph frequency response of input frequency versus the output voltage, and expression for the cutoff frequency. Is it clear now? Okay. So next let us pass on to the second type of filter. That is the second type of filter is the high pass filter. High pass filter construction is very simple. Before that, what is meant by high pass filter? High pass filter is a filter which allows only higher frequencies stopping lower frequencies. So this type of filter is a high pass filter. In the previous case, low pass filter, it allows only lower frequencies and stops all the higher frequencies. But in this case, it allows only higher frequencies, but it stops lower frequency signals. Okay. And how it is constructed? Construction of the the high pass filter. Construction. Construction is very simple. It just interchange the capacitor and the resistor positions in the low pass filter. So we have an input AC source, and it is connected to a capacitor. Here, and then it is connected to a resistor in series. R is the resistor, C is the capacitor, and I am going to select the output voltage. Across the R. Here I am going to take output voltages. Okay, this is input voltage. So this is the formation construction of the high pass filter. Very simple. Low pass and high pass, C and R are going to be interchanged. In the low pass filter, R comes first and then C. Whereas in the case of high pass filter, C comes first and then R. We are going to measure the voltage across the C in case of the low pass filter, but we are going to measure the output voltage across the R in high pass filters. So these are the differences. We can list out the differences at the end. What are the difference between the high pass and low pass filters? Okay. So right now the construction is very clear. Okay, we have a voltage source. The source is connected to the capacitor, and then it is connected to the resistor, and then the resistor to the voltage source, and we are going to measure the output voltage across the resistor. This is the simple construction of the high pass filter. Okay, now how it works? Working also very simple. Working of the high pass filter. So XC impedance, reactive impedance, capacitive impedance, XC is equal to 1 over omega C. This is equal to 1 by 2 pi FC. Okay, 1 by 2 pi FC. As this F is low, XC is more. Whatever the input we are going to supply, everything is stopped at this particular end. Capacitor does not allow the input signal to pass through it, lower frequencies are not allowed. Lower frequency signals are not allowed because of higher impedance. Impedance of the capacitor is very high at the lower frequency level. Lower frequency values, the capacitance, reactive capacitance or impedance of the capacitance will be more. Therefore, it does not allow the signal to pass through it. All lower frequency signals are completely stopped at the capacitor end itself. So, across the resistor, we did not record any kind of voltages. So, lower frequencies are completely attenuated. Is it clear now? Because of the higher frequency, higher impedance. Now what happens if I increase the frequency? If I increase the frequencies, automatically the impedance value goes on decreases. If F is more, Xc is less. F is less, Xc is more. Okay, so F is more, Xc reduces. So if I increase the frequency here, the capacitive reactance or impedance of the circuit will be less, goes on decreases. As it decreases, the output will be appear across the resistor. Output appears across the resistors. So the output begins to increase from a particular value. That particular value we can decide. We can design the filter based on our requirements. As I mentioned earlier in the previous case also, I can design the low pass filter or high pass filter, whatever the filter we are using. We can design the circuits based on our requirements. Okay. So based on the values of R and C which I am going to use in the construction. That's all. Very simple. Okay. So higher frequencies, the capacitance impedance are going to be reduced. Therefore, output appears here. Or the circuit acts as a high pass filter. So higher frequencies are allowed and lower frequencies are stopped. Okay. So for this, what is the frequency response? I write the frequency response here. So this is the frequency response. I'm going to take the frequency along the x-axis and voltage along the output voltage along the y-axis. So the lower frequency are not allowed. These are not allowed. So after particular frequency it goes on increases and it reaches a maximum. So this particular part is allowed. This particular part is allowed and this is not allowed. Okay, this is not allowed and this part is allowed. So this kind of filter circuit is what is called as the high pass filter. Okay, this frequency is a cutoff frequency, FC. Cutoff frequency. Is it clear now? What is the construction? How it works? Okay, why it is called as the high pass filter? Because it allows only the higher frequency ranges and completely stops the lower frequency ranges. Now, what is the expression for this? What is the expression for the cutoff frequency? Expression for the cutoff frequency. Expression for the cutoff frequency is the expression for the cutoff frequency. As usual, we have to apply a voltage divider rule. Voltage divider rule here also. Voltage divider rule we have to apply. That is V out. V naught is equal to R divided by, in this case R divided by R plus XC into VI. I'll take this VI to the denominator here. V naught by VI is equal to R divided by mod of R plus XC. Okay. So now mod of R plus XC is equal to square root of R square plus XC square. We have to apply this here, and at resonance, V naught is equal to 1 by 2 times VI by root 2 times VI. Therefore, right here itself 1 by root 2 times VI divided by VI is equal to R divided by root of R square plus XC square. And VI get cancels. We have 1 by root 2, that is equal to R divided by square root of R square plus XC square. So take the square root on both sides. Taking the square root on both sides, I am going to get 1 by 2 is equal to R square by R square plus XC square. So cross multiplying, I am going to get R square plus XC square is equal to 2R square. So XC square is equal to 2R square minus of R square. So XC square is equal to R square. So square get cancels. We have XC is equal to R. XC is 1 over omega C, that is equal to R. Omega RC is equal to 1, or 2 pi F into RC is equal to 1. At the same time, F is equal to cutoff frequency, F is equal to 1 divided by 2 pi into RC. So this is the expression for the cutoff frequency in case of high pass filter. So from this expression we came to know that the cutoff frequency for both low pass and high pass are one and the same. It only depends on R and C value, and the position of the R and C decides whether it is a low pass filter or an high pass filter. If R comes first in series with the input source, then it will be a low pass filter. If C comes first along with in series with the input source, then it will be a high pass filter. So cutoff frequency in both the cases is the same. So what is meant by a cutoff frequency? What is meant by cutoff frequency? What is meant by cutoff frequency? We have to define cutoff frequency here. Okay. Cutoff frequency. What is meant by cutoff frequency? So cutoff frequency of the high pass or low pass filters are same at some frequency. This is because the capacitor and resistor have the same impedance at this frequency. So cutoff frequency is that particular frequency, the frequency at which the capacitor and the resistor have the same impedance. Okay, same impedance. So this particular frequency is called as the cutoff frequency, or it is also called as the corner frequency. It is also called as the corner frequency. The frequency or cutoff frequency, one and the same. So frequency at which the capacitor and resistor have the same impedance is called as the corner frequency or cutoff frequency. So if we draw the graph of both the low pass filter and high pass filter, it looks like something like this. Okay, so if I write the graph taking frequency along the x-axis and output voltage along the y-axis here. So So this is corresponds to, this is going to be the graph corresponding to the low pass filter. This is for LPF, low pass filter. Okay, and for high pass filter, it is something like this. So this is for HPF, low pass filter. So these two are having the some particular value. Okay, these two are having some particular value. Okay, so this particular frequency is what is called as the corner frequency, FC. Okay, is it clear now? At one particular point, both are having the same impedance. Resistance and the capacitance are having the same impedance. Therefore, they crosses over each other at this particular point, and this particular frequency is called as the corner frequency. Okay. So for low pass filter, below the FC is allowed, above FC is cut off. For high pass filter, below FC is not allowed, above FC it is allowed. So these are the major difference between the low pass filter and the high pass filter. So again, a question may be asked in the examination, right? The differences between the low pass filter and high pass filter. For that particular question, I will write the answer here also. Make a list of the differences. Here, low pass filter on one side and high pass filter on the another side. High pass filter on the another side. Okay. So this is the difference between low pass and high pass filters. Let us write the differences here. Number one, what is the low pass filter? It allows only low frequencies. Okay. In the high pass filter, it allows only high frequencies. Right, high frequencies. And number two, second difference, it stops high frequencies. It stops high frequencies, and here it stops low frequencies. It stops lower frequencies. Okay, and number three, what is the third difference? It consists of resistor. It consists of resistor followed by capacitor. But in this case, it consists of a capacitor followed by a resistor, right? Okay. And then fourth difference, I'll write here, fourth difference. Voltage output is measured, output is taken, or I write output is measured, the proper word, measured across C. Here output is measured across R. Okay. So these are the major differences that I can list out here, and you have to be careful about the differences which I mentioned here. So major difference between the low pass filter and the high pass filter. I think this is the end of this particular small topic which I discussed now. What are filters? What are different types of filters? What is a low pass filter? What is a high pass filter? And what is a low pass filter, how it is constructed, how it is working, and what is the frequency response graph and expression for the cutoff frequency, and also the high pass filter, expression for the cutoff frequency of the high pass filter, major difference between the low pass filter and the high pass filter. All these things I have discussed, and also definition for the cutoff frequency. So we have discussed. I think this is the better input that I have given to you for the point of examination. Study well. If any questions comes in the examination, you can